I just want to let you know that I actually just added another angle before I started my lengths. Knowing this triangle here, okay, knowing that that's 60, and I've just written in that that's 80, which would make this number here 40. Alright, now you need to decide which triangle you're going to use to get your final distance. Alright, I'm trying to get this distance here, okay, CD. Alright, now you can either choose this triangle or you can choose this triangle. It doesn't really matter which one you choose. I've decided to use this one, okay, which means I need to know those two dotted lines. I need to know the value of those two dotted lines. So if I work with what I know, which is this 126 kilometres, all right, and its opposite angle, that's absolutely essential to know that opposite angle there, all right, and I try to work this one out first, all right, and I know that that length there, that angle there is 130. So if you just redraw that for yourself to save confusion when you're looking at it, okay, 130 degrees, don't know this is 126 kilometres, and down here is 30 degrees. So I've just literally copied this little triangle here to make my life a bit easier when I'm looking at it. Alright, so using the sine rule, you've got pairs of opposites, okay, put your unknown on the top, so x over sine 130 equals 126 over sine 30. Alright, and then x equals 126 sine 130 over sine 30. Alright, and you'll discover that equals 193.04 kilometres. Alright, so you have 193.04 kilometres across the centre there. Now let's work on this guy. We need to know this value here as well. So let's work with this triangle now. Alright, you've still got your 126, now you're dealing with your 40. Alright, your unknown, and it's 80. Alright, so I'm just going to do that over here. Unknowns, this is my unknown here, let's call it x for a second. So x over sine, what's his opposite? It's this thing over here, 80, equals 126 over sine 40. Alright, so x would equal 126 sine 80 over sine 40. Okay, and strangely enough, it actually comes out to exactly the same number. Alright, so this is actually, I'm just going to write it this way, 193.04 as well, just by chance. Alright, now that says something about this triangle. Alright, if that's 193.04 and that's 193.04, then what you've got is an equilateral triangle, an isosceles triangle, excuse me. Alright, so you've got an isosceles triangle, so we know that this angle, whatever it is the same as this angle here. Okay,